In this module, we are going to study about the effect of frequency on stopping potential and kinetic energy maximum. Students, starting with the effect of frequency on kinetic energy maximum, we know that if the frequency of the light or the incident radiation, if it goes on increasing, then the energy of photon also goes on increasing. How do we know that? We know that from a formula E is equal to h nu. H is constant. So if the frequency increases, then the energy of the photon also has to increase. We know that if the energy of photon goes on increasing, then the kinetic energy of the electron also goes on increasing. That means electron is moving with more velocity. It has more kinetic energy. If the kinetic energy goes on increasing, we know that the work done to stop it should also increase. But currently, we are limiting ourselves only to kinetic energy. So we know if the frequency increases, the kinetic energy also has to increase. And if frequency and kinetic energy are increasing, then like that, I know that they have a relation between them which is direct. So I can say that the relation between frequency and kinetic energy is direct, and the graph between them has to be a linear graph. So when I draw the graph between them, I get a graph like this. In this you can see on x-axis I have frequency and on y-axis I have kinetic energy maximum. That means if the frequency goes on increasing, then the kinetic energy will go on increasing according to this linear graph. But why do we have frequency on x-axis? Because it is an independent term and kinetic energy depends on frequency. That is why it is on y-axis. The graph cuts the x-axis at nu naught. The reason why it cuts the x-axis at nu naught is because if we have less frequency, the photoelectric effect will not take place. And if it does not take place, there will be no kinetic energy. There will be no electron coming out, and hence no photoelectric effect will take place. So the photoelectric effect takes place after a frequency nu naught, and hence the whole graph will start from nu naught, and from the nu naught we will have the kinetic energy go on increasing. So we move on to the next graph. The next graph says that the effect of frequency on the stopping potential. We know that if the frequency goes on increasing, then the energy of photon also goes on increasing. If the energy of photon increases, then the kinetic energy of the electron also increases. If the kinetic energy of electron increases, then the work done to stop it must also increase. And if work done to stop it increases, then the stopping potential should also increase. That means I can say that the relation between the stopping potential and the frequency is a direct relation, and hence the graph is a linear graph. Again we are getting the graph which cuts the x-axis as nu naught. Why? Because we know for less frequency we will not have photoelectric emission taking place, and hence we will not have any stopping potential. So students, from this whole module we studied the effect of frequency on kinetic energy maximum and effect of frequency on stopping potential. Thank you.